Video is about mostly about the scientific method. Basically, scientific method is always going to start off with some kind of observation. Observation makes you go, I wonder why that happens, or how that happens. Then you start researching. You research because you need to find out what other people know, what other people have investigated, what other people have found out. And you use that research to form your hypothesis. We could easily make a hypothesis that says honey's like flowers because, bees like flowers because the bee thinks the flower is pretty. Okay? But if we did research first, we would find out that the bees are going to the flower and they're carrying something from the flower back to the hive. So that's why they like the flowers, the pollen and the nectar. Mainly the nectar. They need the nectar. The pollen they just transpose that and pollinate flowers. After we have a hypothesis, we are usually going to do some kind of experiment. Now the experiment has to have a control that's not altered at all, so we have something to compare to. And it has to have an independent variable that we change and a dependent variable that changes as a result of what we did. As the experiment is conducted, we collect data. And once we have the data, we use the research and the data to form a conclusion. Now, a conclusion is where you put everything together and you decide whether your hypothesis was correct or incorrect. And as I've said before, incorrect is okay. It just means you eliminated a possibility. So, let's take a look at the science fair steps according to your packet. Alright, switch to a highlighter here. So first of all, you have to ask a question. Once you find a general topic that you are interested in, start looking for something that you can test. You might be interested in cooking, so maybe you test a different way of cooking rice. Maybe you test a different way of making cookies. Just be careful with some of these experiments because some of them may be below your grade level. So make sure you're doing something that is at your grade level. So we're usually going to start with how, what, when, who, which, why, or where for our question. The example they give, how much current does a robot's arm use to lift a weight? Now that's your question. That's what you're starting with. Maybe you observed a robot arm lifting something and you decided to investigate how much current it takes for the robot arm to do that. So next we do research. Research, again, is where you are looking, for information about robots. You're looking for information about electricity, how robots work, how electricity works, how does the electricity power the robot. Right? That brings us to the hypothesis. So a hypothesis is an educated guess about how things work. Most of the time, you should have an if-then statement. An if-then hypothesis means if I do this, then this will happen. So maybe if I supply 20 amps of electricity, the robot will be able to lift the arm or lift the weight. If I reduce the current, the robot arm will lift less weight. If I increase the current, the robot arm will lift more weight. The hypothesis needs to be testable. It needs to be testable. We cannot test whether or not an asteroid hit the Earth and killed the dinosaurs. Because, well, we can't go back in time, and it'd be really sad if we crashed an asteroid into the Earth to see if it destroyed us, because we'd be destroyed. So we can't test that. Now, there is a lot of evidence that suggests it did happen, but we can't exactly test it. Right? Raising the temperature of a cup of water, temperature is the independent variable, will increase the amount of sugar that dissolves. So the amount of sugar is what you measure. That is your dependent variable, because it depends on what you did to the temperature. Did you raise it or did you lower it? How much did you raise it? How much did you lower it? Okay? So a hypothesis for this, think about that. How, for this right here, how might you write an if-then hypothesis? So take a moment. The teacher can pause the video and take a minute or two and think, use your think time to come up with an if-then hypothesis. Alright, now that you've had some think time, you should have come up with something, and there's different ways you can do this, but maybe something like if the water temperature is raised, then more sugar will dissolve in the water. That's an if-then hypothesis. Okay? So if I do something to the independent variable, then something will happen to the dependent variable. And our hypothesis is our educated guess, our prediction about what that change will be. Next we have the variables. We've already talked about these briefly. The independent, that's what you change. The dependent, that changes as a result of what you did. And we have controls. These stay the same throughout the entire experiment. Maybe you're testing the amount of sugar that dissolves in water. So maybe you have one cup that's got hot water in it, and you have another with room temperature water, and then you have another one with very cold water, or at least colder than room temperature. So this would be the control, and then this would be the independent variable. And I suppose if you use the cold as well, that would be the independent too. So take 10 seconds, silent think time. What would be the dependent variable in this experiment here in red? And the dependent variable is the amount of sugar that dissolves. Okay? So one of these may have more sugar dissolving in it than the other two. Another example of control, if you are going to do something with plants, maybe you have one plant that gets regular soil. Maybe you have another plant that gets the same soil, but it also gets fertilizer. Okay? So how do you know that the fertilizer works? If you just have the one with the fertilizer and your plant grows really well, that's great. But maybe it would have grown really well without the fertilizer. You don't know that the fertilizer made a difference. But if we have the same kind of plant in a pot with just soil, no fertilizer, then we know if this one grows and gets really big and this one doesn't, then we know the fertilizer made a difference. Or, and this happens sometimes, maybe it doesn't really get any bigger. It's about the same size as the one in the soil. That means the fertilizer didn't make a difference. Or it's also possible the plant could die. Maybe the fertilizer was too strong. Maybe you gave it too much fertilizer. Okay? That would be a whole nother experiment. So those are, those are variables. So here we have a example. We have the question, the independent variable, what you change, dependent variable, what you observe, what you measure, and the controlled variables. I'll let you read that on your own. The procedures are just that. You have a list of materials and a list of steps that take you through it. The experiment is very important, that you take detailed notes, because you never know when you might have to go back to something and go, ha-ha, that's important. Maybe it wasn't important at the time, but it might be later. Of course, graphing. You should have graphs. You can have pie charts, bar graphs, line graphs. Depends on what kind of data you have. When you review your data, you know if it's complete or not. Do you need to collect more data? Do you make any mistakes? If you made a mistake, you might need to account for that in your analysis and conclusion. You might even need to go back and redo your experiment, because maybe the mistake made a difference. Maybe it didn't, but maybe it did. Find the average of your data. Make sure you label everything clearly, especially your graphs and charts. Make sure to include the units. Okay. I always tell students, if I owe you $5 and I give you 5 cents, have I paid my bill? No. But I gave you 5. I gave you 5 pennies. So the units are important. Okay. Place your independent variable on the x-axis, and the dependent will go on the y-axis. So in our earlier example, if we were measuring the amount of sugar and temperature, the independent variable would go here. So this is temperature, and this would be the sugar, or the amount of sugar, and we would see some kind of line, most likely, that as temperature goes up, the amount of sugar goes up as well. Alright, so that brings us to the conclusion. Now the conclusion is very important, because this is where you tie everything together. You tie the research, the hypothesis, the data, the analysis of the data. All of it comes together in the conclusion. It's one of the most important parts of your report. Okay? So you're going to summarize your results. You're going to state whether it supported or contradicted your hypothesis. You're going to talk about a relationship between the independent and dependent variable. There's 2 here that you could talk about. You may or may not have talked about these in math or science class, but there are direct relationships. In a direct relationship, if one thing goes up, the other thing goes up. Or, if one thing goes down, the other thing goes down. So that's a direct relationship. In a inverse relationship, if one thing goes up, the other thing goes down. Okay? So think of it this way. The amount of studying you do is directly proportional to your grades in very many cases. If you study more, you make better grades. If you study less, your grades are less. The amount of practice you do for the basketball team is directly proportional to your performance. The more you practice, the better you perform on the court. An inverse relationship. Oh, money. The more money you spend, the less money you have. Okay, so that's an inverse relationship. All right. Summarize and evaluate the procedure. Make comments about the success and effectiveness. Was there something that you would change in the future and do differently? Suggest changes in the experimental procedure or design. Okay? Because again, you're a scientist. You're doing science. You're going to report your findings to the world, and other scientists are going to look at it, and they're going to how would I do this differently? Right? So they're going to be looking to see what you would do if you did this again. All right, now, the abstract is an important part. It's like the back cover of a book. If you've ever picked up a book at the library or the bookstore or your teacher's bookshelf, you turn it over on the back and you read the little blurb on the back. That's an abstract. It's enough information to get you interested and make you want to read the thing. All right? So for most science fairs and ours, the abstract should be about 250 words. It is at the beginning of your report as well as on your display board. It has 5 pieces. Introduction. You describe the purpose for doing your experiment. Why should anyone care about your experiment? Did you explain something that should cause people to change the way they go about their daily business? If you made an invention or develop a new procedure for doing something, is it better or faster? You want to motivate the reader to finish reading not only the abstract, but your entire paper. Okay? Just like the back of the book motivates you to read the book. Okay? The problem statement. This is the problem you solved or the hypothesis you investigated. Your procedures. What was your approach for investigating the problem? Don't go into detail about materials unless they were very critical to your success. Okay. These are where you describe the most important variables you have if you have room. Then you're going to talk very briefly about your results, and you're going to talk about your conclusions. Right. So that is pretty much that. So that is the science fair project and everything put together, and I'll see you next time.